Incrementing and decrementing is something that's used in software all the time, and sometimes that needs to be done with arrays. And luckily, LabVIEW has two pre-built .vim. LabVIEW has two pre-built nodes to handle this. So we have an increment array element and our decrement array. I'll grab the increment array. And this place, I'll just plug, yeah, cut all that out. So if we run this, we can see all of our numbers got added to 1. The .00, the decimal point, is because these are doubles, but I'll talk about data types in a later video. So depending on your data type, you'll get your output, but it added 1 to every. Oh, it didn't. Oh shit. Hold on. Oh no, I didn't know that. Okay. So when we run this program, our 0th element got added to 1. And notice that all the other elements stayed the same. The Desmo.00 is because that these numbers are doubles, but I'll talk about data types in a later video. So what this does is only incrementing by 1 the element that is selected by the index. So for example, now I've changed my index to 2. Now this 30 got incremented to 31. Same can be done for the decrement side. So I'm just using the same input array. And when I run this code now, I'm set to 0th element, so now our 10 got turned to 9. Same if I was to go to index 2, our 30 got turned to a 29. And same thing with the decimals, these are just doubles. So this is increment and decrement an element. Personally, I've never used these. These are features in a little bit newer versions of LabVIEW and may not appear in the version you might be using. So I have a personal library of pre-built LabVIEW VIs and sub VIs that handle a lot of these functions, and I'll cover sub VIs and stuff later. But if we do double click on these, because they're .vim nodes, we can see the front panel. And if we go to the show block diagram, we can actually see the back panel of what this node is doing. So pretty straightforward what it's doing. It's just taking the array in. It's using our place element structure, which I've talked about in a previous video, and then it's just adding 1 to the element that is selected. Because this is something built from National Instruments, it does have this ignore case, and I'm not 100% sure. Oh, I think I know why. You've connected a scalar type. Pause. Oh. Pause the video. For many applications, though, only changing one element at a time is not desirable. But we can double click on the .vim nodes, and if we open up the block diagram, we can actually see how it is working. Notice there's a type specialization structure, which I've talked about before, and also a in-place element structure, also talked about before. But if we click, this case is now ignored, and we can see why. This is just one integer, and it's trying to go into an array size node, and then this for loop. So what this node is doing is it's noticing that this is just one integer and not an array. So it's ignoring this case and going to this case. But that means we can put an array in here, so this case will be ignored, and then this case will be accepted. So now when I run this code, we can see our output array, our +1, every element got added 1. And if we remove this index, now the same is done for minusing 1. So everything got subtracted 1 on this side, and everything got added 1 on this side. This is a really bad way of doing this, though, just plugging in an array into this. And that's where these structures like a for loop or possibly a while loop can be used, and then the indicator on the while loop, that'll actually be plugged into here. But this is just a way to show how these two nodes operate and how they work. So hope this was helpful, and stay tuned for more.